And now for the p-scale, what we have to do is we have to also fade the size of these curves as the lining progresses through the simulation. So this will be done in the same manner that which we did the amplitude for that dir vector that was used in the force in the .NET. And we will use a solver for this. So let's go look for our simulation points up here at the top. Let's grab the SimPTs and bring this over. And just copy this object merge and paste this here. So these are our simulation points. So we will use the same transfer thing that we did earlier, and let's set these to have a color of black. So after our set n, let's set this to black, copy this over and set this to white. And we want to attribute transfer inside a solver. So drop down a solver from here, place this into our second input, and let's drop down on attribute transfer, select our CD, and let's plug our second input inside here, and maybe drop down an output node as well. So let's promote this distance threshold to the top level. Let's go up, and for my solver, edit parameter interface, and let's drop our distance threshold inside the root and hit accept. So now let's go up and let's start maybe with a value of 1 and see what this will give us. So if I play the animation, we can see that maybe this is a little bit too low. We are not capturing all of the points, so maybe just increase this threshold. Okay, so let's try maybe a value of 4 or 3. So a value of 3 in my case will be fine. So again, we have to be mindful that our timing of the simulation changed. And let's go ahead and also copy the time shift and the retime node. Let's do an action and create a reference copy and bring this over to the simulation points. So let's drag these out and let's place them after the SimPTs and before the color. Alright, so if I preview now, our animations should match. So now we can say that when these points receive a color value of 1, they will start increasing in age. So drop down an attribute wrangle after the transfer and say that if your color is bigger than 0, then I will set the age to be plus equals 1. So if I go up and resimulate, when they turn white, they should start increasing in age, as we can see here. Let's go back, and now we can use this age to create the animation. So let's drop down an attribute VOP, and this will be our p-scale. So set p-scale and plug this in our template points, and let's step inside. Let's do a bind and grab this age, and I will fit this to a new range and promote the source max. And if I place this directly into the p-scale, let's see what happens. So bind export this to the p-scale. And let's go up and let's preview the copy to points. And maybe let's start with a maximum value of maybe 25. So now what we can see is they are slowly incrementing over time, all the way up to a value of 1. So let's add a global multiplier for this p-scale. Let's get rid of this geometry VOP and drop down a multiplier after the fit. And let's promote the second input. And I will set this to global multiplier. And let's go up and start with a value maybe of 2. And let's also maybe visualize this from our camera. Okay. Maybe I think 3. And let's go back inside, and before this global multiplier, let's drop down a ramp from the fit. So set this to a spline ramp, and I'll rename this to maybe a ramp age, and also give this a name, ramp age. And let's go up. So I want these to start fast and die out slow, so I will adjust this ramp until I get the desired result. But we should start from something that looks like this. So now over a period of 25 frames, these will start with a p-scale of value, and maybe over 5 frames they will increment, or rather increase, to a value of 1, and then slowly decay over another maybe 20 frames all the way down to 0. Let's set all of these handles to be B-spline and just adjust this a little bit. So create something more smooth and maybe interesting. So maybe something like this. Okay, and let's preview this. I think these are starting a little bit too big. Okay. All right, so hopefully we can you can kind of see what I'm going with now. Okay. Let's preview with the geometry as well. And let's go back and use the low quality geometry, just so we can play back faster. Okay. We will come back to this p-scale in a bit. Let's maybe turn these into volumes now. Let's drop down from here a transform, and I want to overall just move these a little bit slightly below our geometry. So for this transform, I will maybe decrease the translate Y, just push this in inside the ground a little bit, so maybe negative 0.2. Alright, and let's give all of these lines some geometry now, and we can see that we are only working with 2 points per line. Let's drop down a resample and let's preview the result. Maybe a length of 0.1, maybe 0.05 will be better. So essentially, where there is a point here, we will have now instead a voxel. So if I drop down an attribute wrangle and I just want to create a density attribute, which I will just set to 1, I can from here drop down a volume rasterize attribute, and let's set the particle scale to be equal to my voxel size for now. So drop this here and place a relative channel. So now these are linked. Let's set this back to 0.1 and rasterize the density as attribute. So now if I preview this, we should have smoke. And maybe let's drop down this to 0.5. So we have a finer volume. And also maybe I want to taper these towards the ends a little bit. So from this resample, I will generate a curve view attribute. And instead of giving this density a flat value of 1, let's map this to the curve view attribute. So let's set this equal to chramp, and I will set the name to be density ramp and map this to the curve view. So if I create the channels, let's go back to the volume rasterize and see what happens. Let's maybe turn off the geometry. So I think this is the other way around. Let's reverse the ramp. Okay, so now our edges are sharp. So we can see that we also have some points over here that shouldn't be rasterized, and we can clean this up if maybe... So maybe here, after we set the p-scale, I can drop down an attribute wrangle and say that if your p-scale is 0, then we will remove that point. So let's do remove point 0 and ptnum. Alright, and let's go back to the rasterize. So now we get rid of these small points. Okay, so this is looking good. Let's go in our camera